unpack the breadth of Axiom managed payloads is one who has helped every principal investigation team prepare for this mission, our very own Chief Scientist, Dr. Lucie Low. She's at Kennedy Space Center in Florida with Axiom Space Director of Digital Strategy, Sonia Gavankar-McKay. Sonia, great to see you, and we're excited to understand what's ahead in the next couple of weeks for our crew.
Thanks so much, Duke. It's great to be here with all of you as the excitement really builds toward launch. We're just a few miles away. In fact, you may be able to see the Falcon 9 rocket with the Ax-2 crew on board just over my shoulder. And yes, I'm joined with Axiom Space Chief Scientist for Microgravity Research, Dr. Lucie Low. Lucie, how excited are you for what's to come?
Hi, Sonia. I mean, it's a fantastically exciting mission. There is an absolute massive amount of research that the crew is going to be doing, and I can't wait to see them get started.
And there is a massive amount of research they have to do, and we have just a little bit of time to cover it, so let's dive right in. It is packed for it, but what has been the scientific strategy for this mission, and what do we expect to see?
So the scientific strategy is really continuing what we did on Ax-1, which is expanding access to microgravity for a whole new global community of researchers. So we're really excited to welcome on board our Saudi Arabian partners and see them do the research they want to do. We also have some opportunities to expand commercial opportunities by manufacturing products in space that could be beneficial for life here on Earth. So we have a glut of projects that are going to be doing all kinds of stuff about in-space manufacturing. So we're really excited about those.
Now, you've organized the portfolio into 5 main categories, and we're going to kind of touch on each one of them very briefly. Let's start with physical sciences. I noticed that from the list there is radiation protection research as well as some storm-related research that is looking at how weather and climate and seeding clouds. Tell me what this all means.
Exactly. So we have a really fun experiment that's brought from us from the Kingdom of Saudi Arabia looking at cloud seeding. So they're looking at how silver iodide crystals can actually form water vapor in a specially designed chamber. So they're not only understanding how cloud seeding could be more effective here on Earth, but they're also looking with a vision to perhaps extraterrestrial agriculture, so maybe growing crops on the moon and in Mars in future.
Wow.
We also have projects looking at radiation shielding, so the sun spits out a bunch of radiation. So looking at how different kinds of polymers could actually protect the electronics on the space station could actually help with future spacecraft design. And then finally, you mentioned storms. We have some really fun projects where the crew are actually going to be trying to capture images of what we call transient luminous effects, which are events which occur just above thunderstorms at the same time that lightning strikes. And we can't see them from the ground because we're underneath the clouds. So on top of the clouds, we can see these phenomena, and it helps us understand more about our own weather and climate down here on Earth.
Excellent. So the next portfolio is life sciences. Research includes DNA, nanomaterials, and reprogramming skin cells to help create regenerative medicine. There's also research planned to build on Ax-1 science modeling tumor organoids to better predict and treat cancers. Can you break down a few of those for us and tell me again what we can expect to see, what the astronauts will be doing up in space?
Yeah, absolutely. So as I refer to some of those in-space manufacturing projects, so the DNA-inspired nanomaterial that you referred to could actually be used as a therapeutic delivery agent in future, or as a scaffolding for degenerating joints. We have also projects looking at 3D bioprinted tissues, so looking at liver and kidney and seeing how they respond in microgravity, which could be potentially very informative for helping us understand regenerative medicine efforts. And then we have a whole other project on stem cell manufacturing, which could actually then help with lots of kind of clinical applications here on Earth. So lots of research on that end, not even to mention all of the human research that our crew are very willing participants in, where they're doing all kinds of experiments to see how the human body responds to space, how it adapts to microgravity, and how we can use that knowledge not only to make space travel more safe for humans in future, but also help us understand our own physiology back here on Earth a little bit better.
Okay, on to tech. The research being conducted here seems to be how can we automate more to take up less time doing things like data transfer. We know about that on Earth. What's it like up in space? Making communications with Earth easier and literally tracking where supplies and materials are on board. I mean, they have a lot of space up there inside the building, right? So they have to be able to track where everything is, loose bolts and whatnot. What stands out to you in this research?
So it's interesting you mentioned how much space there is up there because there's fairly limited space.
Yeah,
so we have some, they can't exactly. So we have some Axiom technology demonstrations where we're demoing some of our own technologies that we can use on Axiom Station in future. But we also have some really fun technology demonstrations from our partners that are sampling the air inside the ISS.
Oh.
They're using special sensors called quartz crystal microbalances that can detect tiny molecules in the air and tell us a bit about the air quality inside the ISS.
Wow.
And then we have a really fun project from the MIT Media Lab where they're looking at what they call a gravity countermeasures loading suit or a skin suit, which actually models some of the effects of gravity on our crew, and so it helps them prevent some of the physical deconditioning that astronauts see when they go into space.
Really important research.
Absolutely.
What do you think the air is like up there?
I hear it smells of electronical equipment.
Oh, okay.
So
we'll wait
yeah.
for those little cubes to tell us a little bit more information
Exactly,
and figure out
yeah.
how we can scrub it. Okay. Partnerships also very important with Axiom Space since it started, and it's really great to hear about all of this research that's really coming from so many institutions, educational organizations. Lucie, how are you seeing the commercial opportunities evolve, and what's the goal for us long term?
Yeah, absolutely. Great question. So we continue to expand our partnerships with a number of global research communities, which is really exciting, seeing really exciting research come in from new communities, new organizations, new researchers that have historically not had access to microgravity, and now we can provide that. But as I said, we're also very interested in opening up these new commercial economic opportunities to do things in space that can create materials or biomedical products that can benefit life here on Earth. Because that's ultimately what we want to do at Axiom, is everything we do in space, we want to be benefiting every human everywhere, which includes not just the astronauts, but all of us back down here as well.
Well, thank you so much, Lucie, for all your time. We're going to be talking to you during the mission as well to find out a little bit more about what's been transpiring up in space, what we expect to see down here, and so much more will come our way. Thank you so much, Lucie, for your time.
Thank you, Sonia.
Well,